Thing I will mention before we start on this one, you'll notice the top of your paper, and this is the actual homework paper, won't look like mine.
Wasn't it front and back? No.
Because what I did is I rewrote the most common perfect squares that we're going to need to use. The ones in red are the ones that we're going to use in breakdowns. So once we figure out the breakdown of these numbers, that's going to help us to be able to finish some of these off. So I will have the calculator here in handy. And we'll just kind of jump in. I'm going to work down the left side on some of the odds with you. Even though the assignment's like all, we're just going to knock out a bunch of these together to kind of help out. So here's our deal. When I'm doing the number part of these, I'm almost always going to have square roots with both of these, where there's going to be two of them. My idea is, yes, sir?
The square root of the number that times the same number times that number.
Sometimes, if it's a perfect square, yes. But in this case, 125 isn't a perfect square because I don't see the number anywhere across the top of the paper. So, sure. All right, so when we're doing these, no, it's still me.
Oh, okay. I thought it was a video.
No, we're becoming the video.
Yes.
So, here's what we're going to do. I need to find two numbers that multiply to 125, one of which is in the list. All right, 25 and 5. Now, this one I hope would have been a little bit easier because it's kind of a sensible that 25 would go into 125.
And then 5 and 5.
Right, so, but let's not get too far ahead of ourselves here. If you're not sure sometime, you're like, well, but I don't know off the top of my head that 25 times 5 is 125. You know, how do I make this work? Right, that's perfect. You're going to take whatever you're doing, and you take a number, and you try dividing some of the red numbers in until you find one. Oops. Let's try it one more time. Until you find one that works. So 25 and 5. Now, Dustin even took it a step further and said square root of 25 is 5. That gets out of radical jail. It's on perfect behavior. It's a perfect square. 5, though, isn't in my list of red radicals. It's got to stay inside the square root, inside radical jail. Now, the one other thing we talked about yesterday was how do we deal with the variables. So here's how the variables work. If you don't see a number out here, a little number, this is called a root. Since these are square roots, that number is going to be 2 every time. And that's important when we get to working with the variable part.
Can we call them square roots?
No. So, here, what I'd ask myself is, how many times does 2 go into the exponent? Well, here's the problem. Does 2 divide into 1?
No.
No. So that n has to stay in radical jail too. It can't get out. I have to be able to divide into the exponent to be able to have the part of it get out. And that's all I can do. Now that might look weird for an answer, but it is the answer. That's as far as I can go. So as I start to work down on these, so let's say we hit up number 3 here. Now this could be a little more challenging. Now, 512, I wouldn't expect you to know off the top of your head. I even have to think about it a little bit.
I think you know everything.
That's
Okay?
Wait, why are we doing that?
Okay, because 512 is our next number. Huh?
Why are we splitting up 5
The little, hang on. The little 2, this one,
No, there's a 2 next to it, doesn't it?
over here,
Oh.
that's only on my,
2.
this guy.
Number 2. Up top.
I know. I'm going straight down, though.
Yeah.
Yes.
Okay.
Yes. Nice. Okay. Because let's say I didn't know that it was 64 right away. I might try to start doing some of the bigger numbers just to see. But if I get a decimal, that doesn't help me.
Wait, so what is this 64?
So it sounds like Brandon said 64 and 8. Yes.
No, he just said 64.
So 64 and 8. So the square root of 64 is 8. The 8 is going to stay in radical jail here because it's not in the perfect red radical list. But, sure. So, at this point, now I look at the variable part.
Fly.
Hey,
No, it's a bullet.
my exponent is 2, and I divide the 2 in. How many times 2 go into 2?
1.
1. So that means k to the 1 comes outside. However many times it'll go into it, it'll divide in, is that. If,
K1.
Put the 1. Like, I thought it was always 2.
no, that's only this little number that's with my radical. Exponents can be 1s.
Oh, I know.
Yep.
Wait, so what's the answer?
Well, we're going to check and make sure. 2 times 1 is 2. I don't have a remainder. I'm done. Way.
I don't like this.
I can't help it. We got to do it.
I can't do this.
Sure you can.
When is this really going to affect my math?
Well, the fact that some of you have issues with problem solving and working through something when you get stuck and not quitting, that's the main purpose of this. It doesn't have to do with the math.
I can get through things right now. I just don't see what's going to
Yeah, I once got shot with a BB gun.
Okay.
Boom.
So,
Like, right there, how you problem solving?
so 216. It's not the math itself that you problem solve with, it's learning how to problem solve.
We just make it more complicated with math.
Okay.
Okay. I got it.
I don't like this.
So let's see. 216, 36. I think that's going to be a good call. All right. So 36 and 6. So I look and I say, okay, square root of 36 is 6. It's just a coincidence that these numbers keep all being the same. The other 6 is going to stay under. But now again,
It's in radical jail.
yeah, my exponent's 4. I'm always going to be dividing by 2. That's not going to change. How many times does 2 go into 4?
2.
2, so that becomes my exponent on my k
Nah, I don't get this at all.
outside.
That's okay.
Shut up, Brian.
And then I don't have any remainder left, so I'm done.
So there's always going to be the one. There's always going to be that one about because everyone we've done it's been like the 6 6.
Ah, let's see. I bet you it changes on this one. So,
Oh, you saying it's school?
yes, but only for people that are actually paying attention in
Wait, I'm
class.
paying attention halfway.
That's good. No, halfway. No, then I'll be here halfway.
I only need you for halfway.
Okay.
Could you meet
Yes, sir. Do you have this already?
Jump in there.
Everybody's got it.
Okay, now, here's one where we've got to have a little bit of caution. Because if I do 4 and 20, even though I agree 4 goes in, there's a bigger one. And if I don't get the bigger one, I'm going to have to do it twice. I really don't want to do it twice. So let's check the list again. There's a bigger 16, okay.
How do you know what to do?
Here's basically what I'm doing. These numbers that I've got up at the top, the ones in red, the square roots, every one of these, one of the 2 numbers that I have will be one of these.
Yeah.
I'm trying to find the biggest one that'll divide in. If I'm not sure, I'm basically just going to the calculator and I'm starting to divide numbers. So like for instance, when I'm doing number 7, I've got 80. So let's say I'm like, well, I might have 80. Okay, there we go. Let's say I'm like, well, let's try 49. Well, that came out of decimal. That doesn't do me any good. So then I'm like, okay, let's try 36. And I try that. Crap, that's a decimal. That's not doing me any good.
You said crack?
No,
No, what did you say then?
crap.
Crap, oh.
So when I get to 16, I see that one goes in. And 16's in my list. It's one of my red radicals.
So now you're explaining it, Hardy.
So now, I have been all along.
No, you haven't. You just said 8 divided by that, and then he was like 64, and you're like, good. Mr. Hardy knows all.
So here, 16, the square root of 16
8.
is 4. The one that breaks down perfect isn't in jail anymore.
Which 45.
The 5 stays.
And then you bring some with the 3. Right?
Now, here's where the thing comes with the 3. So what I'm going to do,
Cut it out.
Can I have one more chance?
no,
But you love me.
tomorrow I will, but not today. No. When I'm dealing with my exponent then, I have 3 more ready.
Wait, so you put 3 on top.
So how many times does 2 go into 3?
Tell me how you do it. What do
Okay,
you
I'm always dividing by 2. The 3 is my exponent.
Oh, yeah, because it's square root. So it's
Right.
So,
So 2 goes in once, and you're right, there's some leftovers this time. Because 2 times 1 is 2, and I have a remainder this time. If I have a remainder,
why are you getting 2 times 1?
okay, how many times does 2 go into 3?
Once.
Once.
So it's 2 times 1.
So that's my exponent on my variable that goes outside. And then if I have a remainder left over, once I do the division on it, that's the exponent I put inside.
Why are you subtracting?
Because that's how you do long division.
Okay.
Okay? Just a very simple, very small long division.
But if it's small, why is it long?
Now, when I get up to 9, okay, now we're getting 2 variables.
What's your Nintendo getting away soon?
So, 147, I need help.
Ooh, got it right here.
49.
I was waiting for you to call me, Marty.
Are in 3. I'm sorry, I will get you on the next one.
7.
So 49 and 3.
What? So it would be 7 and 3.
Okay.
I thought it always had to be the top ones, like with 49 and 7.
Okay, 49 is going to turn into 7. The numbers that are up here are what the actual square roots, what these numbers are going to break down into once I'm simplifying them. Hang on. So the 49, I'll let you answer, breaks down to 7. So that's going to come
Oh, I get it.
here.
Yeah, then it's
Okay.
7, 3. And then what do you do with the 2 numbers that
Okay.
are the...
Now,
Just go for what it equals, and I get it.
yeah, so then here,
Like what times what?
so for my m, it's sort of like the one right above. How many times 2 go into 3? 1. So I have 1m out here,
And it's minus 2?
So it's 1.
and I have 1 left, which means I have 1 on the inside. And since these are both n to the thirds, it means the n is going to do the same thing.
We have to do the same thing with...
I don't have to literally do it again since I know the same thing's going to happen. It's just the variable's going to be different.
I don't get it. I hate
And that's what we're up to.
this.
Okay, I'm going to go down to 13 because then I want to show you one thing on the back too. I want to give us a good kickstart on things here. All right, 13. Now, this is trying to trick you.
The last one tricked me.
16. Look up in the list. Yeah, 16's already in the list. It's just 4. It's the one time I don't have to break them up. If it's already in the list, I'll just break it down. I'm done, okay? But now, when it comes to the variable part, okay, my exponent's 4. How many times 2 go into 4?
2.
2, so I have u to the second. I don't have any remainder, so I don't have anything left to put underneath a square root or a radical. And then the v is just like the ones we just got done with. Goes in once. But I've got a remainder of 1, and that remainder has to stay in radical jail or underneath the square root.
Can't be prison.
Sure, it can be radical prison. That's fine.
Actually, prison zone is 5 up here.
I see.
I don't know.
So that's how the front's working. Now, one twist on the back. Sierra, we actually try to do some of this, or at least not be playing when we're going along with this, please.
I gotta find them.
No, not right now. You can fight them later. The fight will still be there. No, the fight will still be there. I'm telling you, it will
I
be.
gotta finish fighting them, otherwise then I can't save the game. If I leave it, it'll just die. And that's not good.
Sierra, put it away. Thank you.
I'm trying to play this game.
Now, when you get to the back, here comes a twist. Let's say we're doing 17. What's that 7 doing out front? Ooh, we're going to ignore that for a minute. We're just going to worry about the 96 underneath.
You saw your I thought I saw your phone.
So,
I thought it was cough. I thought it was
16 and 6. Yep, I was a little ahead, but good call. So when I'm here, I wonder if they've ever seen me with 0 people left at the end.
So then it'll be 4 again. 4, right?
I'm gonna have to start writing up again. This is gonna drive me nuts. So, yes, sure. So the 16 right becomes 4. Okay, I've still got the 6 because it didn't break down. It wasn't perfect. And now I've got my variable to work with. So 3, the 7, it's coming in just a second. We'll get to it as soon as we take care of the variable. So 2 goes into 3 once. So m to the first. Do I have any left over this time? Yeah. So I've got 1 left in here. You're like, okay, but what about that 7? Yeah, the 7 can multiply times the number that's not in radical jail or prison or whatever you want to call it now. So 7 times 4 would be 28. M to the first.
Isn't that 16?
Say that one more time.
There was a 1 in front of it.
Oh, okay, gotcha. Yeah, that's just my radical in there. So the only difference when there's a number out front is when you get to the end, you multiply that number times whatever number is outside with you. All right, let's find one more here. Somebody pick one for me on the back here.
12.
Oh, on the back.
32.
23. 23.
You're not even doing it. You don't have the privilege.
16.
Just say it's
You don't have the- He's like 16, 18.
21.
25.
Fight?
Yeah, you know, 18. 18. That's right.
Tearing
No, wait. Yeah, no.
All right, 18.
Why is mine different?
That's what,
No, it's not mine. I'm sorry, I thought.
Okay, what's the better one?
9.
Or that's not on the back.
you the most difficult one there is.
What is the most
Did I say
difficult?
18 or 16?
26. Okay, that looks pretty nasty.
Oh, yeah, wait. 26 is.
Just pick one, Hardy.
26.
Let's do eeny, meeny, miny.
All right,
It always works.
24. What are we doing? 4 and 6. Okay. So when I break that down, square root of 4 is 2. I know that from my list that I jotted at the front or looking at the sheet we had yesterday. And I'm going to leave lots of room under my radical because I see there's 3 variables this time. So I've got my 2, I got my 6. Now I'm going to start dividing. So how many times does 2 go into 4 for my a's? Twice. Do I have any left over? Nope. So a squared, none underneath. Okay, b. How many times 2 go into 2? Once. None left over. Last one. 2 goes into 3?
Once.
Once. Any left over this time?
One.
1. Bang.
Yeah, I'm saying after school today.
Yeah, just keep telling yourself on the variables. Here, let me pop something up that's just got variables for a second. See if this helps. So for instance, let's say this is what I had. What you do when you're trying to solve these is you say, okay, take my exponent, divide it by 2. However many times it goes in, that's my exponent on the outside of the radical. If I don't have any left over, that's the only part there is. There will be none underneath.
I don't remember doing these last year.
However,
Because I didn't do it or something.
with the y's, that's 5. Now again, it's 2. Two times 2 would be 4. But I have 1 left over this time. If I have any leftovers, the leftovers stay underneath. Okay? So that's all we're doing as far as this whole variable thing goes. Now, tomorrow, I'll do like I did with this one today. I'll put half the answers up in case you need to check.
This one homework?
But then, that's extra credit.
This is homework.
Yes. The one we have been working on is the homework. The one we haven't touched yet is the extra credit.
Ooh.
So that's the route we are
Taking.
on right now.
You guys are mean.